Alright guys, so here we go with part 2 of the section 2.3 notes on linear functions and slope-intercept form. We're going to start with a just quick and easy definition of a linear function. Okay, a linear function is a function that is a line. It's a function that graphs a line is probably a better definition. Okay. And it could be in the format and look like this: f of x equals 2x plus 3. A linear equation is just an equation of a line. And it is usually written as y equals 2x plus 3. And remember, these are the exact same thing because y and f of x are the same. So here, if I take this example, y equals 6x minus 4, I can figure out if this point is... Okay, so to figure out if this point is on the line, all we're going to do is plug in 2 for the x value and 10 for the y value and see if it makes a true statement or not. So here we go. 10 equals 6 times 2 minus 4. 10 equals 12 minus 4. 10 equals 8. That is not a true statement, so no, 210 is not on this line. Okay, that is something that you might see on a standardized test somewhere. Maybe not in quite so simple of a format, but the same concept will apply to other graphs that we do later in the year. Okay, so x and y intercepts. Well, your x and y intercepts are exactly what they sound like. Your x-intercept, that is where the graph crosses the x-axis. Okay, so here, at this point, that's where my graph crosses the x-axis. That ordered pair is 4, 0. For every x-intercept, your ordered pair is going to be a number, comma, 0. Now let's talk about the y-intercept. Okay, this is where the graph crosses the y-axis. So when I look at this graph to the left here, this point is where the graph touches the y-axis. That ordered pair is 0, negative 2. So for every y-intercept, that ordered pair is going to look like 0, comma, a number. The number tells you where it touches the axis. Just like for the x-intercept, this number tells me where it touches the x-axis. So now we're going to talk about slope-intercept form of a line. Like I said, shouldn't be anything new. I'm just doing a little bit of review here. So slope-intercept form is a form of the line in which you can quickly and easily figure out the slope of the line as well as the y-intercept. So here's your formula for slope-intercept form. And the way that you can identify the slope and the y-intercept is identifying m, that is the slope of the line, and the b value tells you what your y-intercept is. Okay, pretty simple, not too bad. So now, for this page, we're going to refer back to the graph we had on the other page. Okay, it says, for the graph on the previous page, use the slope formula to find the slope, state the y-intercept, and then write the equation in this format. So, when I come back over here, my points are, let's see if I can put these up here at the same time. Yeah, the 2 points there are 0, -2, and 4, 0. I can use those 2 points to find the slope. Looking at the graph, it touches my y-axis at -2, so my y-intercept is -2. Okay, now I don't need the graph anymore. So when I get over here, let's subtract our y's, and I'm going to use my alternate formula so that I don't have to subtract upside down. I'm just going to go down the columns. -2 minus 0 is -2. 0 minus 4 is -4. That simplifies to 1/2 for my slope. And we already talked about my y-intercept is -2, so that means b is -2. All I have to do is plug those into this formula. So y equals 1/2 x minus 2. And that's your equation. Alright, so problem 2 from your textbook. This is a 1/5. I don't know why it's showing up a little bit blurry today on here. Let's see if I can blow it up a little bit more. I don't know if that will help. Not that one. No, I don't know why that's not any better. I will just recopy it for you. Okay, this slope is 1/5. And my y-intercept is 0, -3. Okay, so I know that m is 1/5. This is my y-intercept. So b is -3. When I write that equation, y equals 1/5, plug that in for m, x, b is -3. That is the equation with slope of 1/5 and y-intercept -3. Okay, just a couple more problems and that will be it. So I'm going to keep this one to 2 videos instead of splitting it up into 3. Alright, for problem number 3. They asked me to rewrite these equations in slope-intercept form, and then they ask what is the slope, what is the y-intercept. So what I have to do for problem A is work to get y by itself. This is why we did those horrible equations in chapter 1 where you had to solve for a certain variable, because that's exactly what we're doing here. If I want to get y by itself, I have to start by moving the 5x to the other side. So subtract it from both, and I end up with -4y equals -5x plus 16. Notice I put my term with the x right after the equal sign. Okay? Now I'm going to divide everything on both sides of the equation by -4. That way y is by itself. -5 over -4 gives me a positive 5/4 x. 16 divided by -4 is -4. So now, this is my slope, this is my y-intercept. So slope equals 5/4. Y-intercept equals -4. Alright, part B. This one, yes, it's got fractions in it, but yes, you can work with them. These are not bad fractions. Okay, so again, to get y by itself, I have to move this 3/4 x to the other side. So because it's negative, I'm going to add 3/4 x to both sides. And by the way, this is a -1 here. So that's going to give me 1/2 y equals 3/4 x minus 1. Now, to get rid of the 1/2 that's in front of the 2, I'm going to multiply everything by the reciprocal. So multiply by 2/1, multiply by 2/1 here, and I'm going to do it here as well. So that's going to give me y equals, because those cancel right there. 2 times 3 is 6/4. 6/4 reduces to 3/2 x, and that's going to give me -2. Leave your slope as an improper fraction. Do not change it to a mixed number, because remember, slope is rise over run. It should always be as a fraction, whether it's improper or just a fraction on its own. So now that I've written it in slope-intercept form, y equals mx plus b, I know that my slope is 3/2, and my y-intercept is -2. Alright, one more problem and that will wrap it up. Oh, and by the way, I guess you've noticed this is my kitchen table. Doesn't look like my desk at school, so you may hear the dishwasher running in the background. I apologize, but this is the time that I had. Alright, so for problem 4, if we're going to graph this, I've got a couple of options. One that you may remember from Algebra 1 and Geometry is you can make a table, pick values for x, plug them in, and solve for y. You could also find x and y intercepts, but I think the easiest way to graph is using slope-intercept form. So I'm going to take this equation and put it in slope-intercept form. First thing I'm going to do is add my 2x to both sides. So I've got y equals 2x plus 1. Now, we're always going to begin with the b value, which represents your y-intercept. This time my y-intercept is a +1. So I'm going to start on the y-axis at 1. And now find your slope. Slope is equal to 2. Make it a fraction by putting it over 1. And now, from your y-intercept, you're going to rise 2 and run 1 to the right. And I'm going to do that a couple of times. The more points you have, the more accurate your line will be. And we're going to use a box here to draw my straight line because I do not have a ruler sitting at the table with me. Okay. So there is the line y equals 2x plus 1. Alright, and so that is it for section 2.3.